Hello students, welcome to ePhysics. Students, here in this video we will be discussing the chapter Electricity of class 10. Electricity of class 10. Students, before starting the chapter, we must understand few terms. That is, let's start with the first term, that is electric charge. Now students, what do you mean by charge? The definition has been given over here that it is something that if a body possesses. Now let us consider that we have a scale. Now when we already know that scale is a bad conductor of electricity. It is a plastic, of course, yes. Now it is not able to attract any other object nearby it. But when we rub the scale in our hair, when we rub it, okay, in our hair, then what do we see? We see after rubbing it, the scale is able to attract the piece of paper. Why it is able to attract the piece of paper? Because this scale, after rubbing the hair, due to friction, it has gained something, and that something is nothing other than a charge. And because of this charge, the body, that is the scale, was able to attract the piece of paper. So the definition here, it is something that a body possesses by the virtue of which it can attract or repel. So this is what we have learnt as charge. Students, charge is generally denoted by small q or capital Q. And its SI unit is coulomb. When we write coulomb, you have to start with small COULOMB, and if you write the symbol of it, it is capital C. Okay. Now, students, we have two types of charges. One is positive, of course, and the other thing is negative. Okay. Now, let's move to the next. Properties of charges. Students, you might have studied in the earlier classes, maybe in class 6, 7th or 8, that the like charges like we have over here, that is negative and negative. Like charges always repel each other. See, positive and positive, they repel each other. And if we have two charges of different signs, let us consider one positive, one negative, that is the unlike charges. The unlike charges attract each other. Okay. Now, neutral means we don't have any amount of charge in any of these objects, both the states. Okay. Now, how will we consider that if any object is having a positive charge or negative charge? How do we call any object a positively charged object or any object as a negatively charged object? Of course, student, if any object, let us consider any object is having more number of positive particles as compared to the negative particles, then we say that the object is positively charged. And if the object is having more number of negative charge as compared to the positively charged particles, then we say that the object is negatively charged. Clear? This is how we, give the charge to different objects. Now, the second term comes here is current. Okay. Now, the definition of the current is rate of flow of charge is called current. Students, whenever we define anything and if we write rate means divided by time. It can also be written as the flow of charge across any cross section in unit time. Unit time is nothing other than 1 second. Okay. We know the unit of time is, of course, second. So 1 second. Now, charge is denoted by, somebody used to write it with small I. We will write it with capital I. Now, what is charge? According to the definition, the flow of what is current? So, according to the definition, the flow of charge across any cross section in unit time or the rate of flow of charge. Now students, by the time I was dictating the definition, I told you if there is a rate in any definition, you can divide it by time. Clear? So this is the unit of current. Okay? Sorry, that formula of current. Now students, when we find the unit, now what is the unit of current? We know the unit of charge is coulomb and unit of time is second. So we got it over here, that is coulomb per second. We can also write it as coulomb per second. But this unit is a lengthy one, so for this we use a smaller term, that is we call it as ampere. We denote it by capital A. Clear? Now students, these ampere and coulomb are itself large terms. So we take few smaller terms, like if we write milli, okay, milliampere. Milliampere means 10 to the power minus 3 ampere. And students, and if we go more smaller than it, microampere, we used to write 10 to the power minus 6 ampere. There are few more values, we will discuss it later on, while at the time when we will be discussing the question answers. Now, let us define what is 1 ampere of current. If the question is asked, how will you define 1 ampere? Now, students, we know the formula of current, that I is equals to Q upon T. Okay? Now, when we write it, 1 ampere, it is equals to 1 coulomb divided by 1 second. That is 1 coulomb per second, okay, which is equals to 1 ampere. So this is how we define it. In words, we can write it as when 1 coulomb of charge flows through any area of cross section in 1 second, then we say that the amount of current flowing through the conductor is equals to 1 ampere. Okay, so we can write it as amount of when 1 coulomb of charge flows through any area of cross section in 1 second. Okay, then we say that the current flowing through the conductor is equals to 1 ampere. Clear? Now students, how will we find the total number of electrons in 1 coulomb of charge? Let us consider, students, we have a conductor in which there are total n number of particles, where we have n number of particles, okay? Number of particles. Now, and let us consider each particle contain E amount of charge, where it is equals to 1.6 into 10 to the power minus 19 coulomb, okay? We know this value already. Now, total total charge will be equal to n particles multiplied by charge on each particle. So we need 1 coulomb of charge equals to n multiplied by E. Therefore, from this equation, when we simplify it, we get n is equals to 1 divided by E, and the value of E we have already discussed, it is 1.6 into 10 to the power minus 19 coulomb. Okay. Now, after solving it, we get 1 upon 1.6 multiplied by 10 to the power this minus 19. When we shift it upwards in the numerator, it becomes plus of 19 coulomb. And finally, when we solve it, we get a value that is equals to somewhere around 0.625 into 10 to the power minus 19 coulomb. Okay, minus 19 coulomb. Now, for simplicity, students, we used to put only one digit in the left side of point decimal. So when we shift the decimal 1 to the right, it becomes something around 6.25 into 10 to the power minus of 18. Okay, this minus of 18, not coulomb over here, sorry, I mistakenly wrote coulomb over there. So in 1 coulomb of charge, we have total 6.25 into 10 to the power minus 18 number of electrons. Clear? Now, students, what is electric potential and electric potential difference? Here, let us consider we have a plate which is positively charged, and also we have any test charge. Let us consider this test charge is also positive. Okay, positive test charge. Why we are calling it as a test charge? Because we are doing the experiment from this charge only. Now what happens, this is a positively charged particle, this is a positively charged plate, and this is a positively charged particle. Now we need to put this positively charged particle into that plate. But students, we have studied that like charges repel each other, and if the plate, this positively charged plate, is going to repel it, we have to put some force on it. Okay, let us consider we are putting F amount of force in it, and after applying this F amount of force, the body is displaced by, let us say, S. When force is applied and the displacement happened, we consider that to be as work done, and this work done is stored in the form of energy, that is potential. Okay, potential energy. So this is what we call as electric potential. What happened over here? We applied some force on the test charge, and due to the force, the charge displaced by any amount, let us consider S amount. And whenever in any object the force is applied and the displacement happens along the direction of the force, then the work is done, and this work done is stored in the form of energy, that is potential energy. Here we are bringing the objects from infinity. Infinity means we don't know where this test charge was kept. So from infinity to one point, when the charge was brought from infinity to one point, then the work required to be done is called electric potential. Clear? Now let us consider the charge was brought from infinity to this point. Okay, initially it was brought from infinity to this point. Now and again, after applying some more amount of force, the object is moved from here to here. Okay, from here to here. Let us consider F2 amount of force is applied. Okay, the object, after applying the F1 amount of force, the object displaced by S. Okay, and the work done, let us consider it is work done is W1, and this work done is stored in the form of, let us consider, V1. And afterwards, let us apply some more amount of force, let us consider F2, and after that S amount of displacement happened, and this, after applying force, displacement, we got the work done, and let us consider the work done is W2, and this work done is stored in the form of potential energy, let us consider V2. Now when the work done on the charge is done to bring it from one point, this is the one point, to the other point, this is the other point, then this work done is known as electric potential difference. Why we are taking these two positions over here? Because to create a difference, we need at least two positions, and the difference between the work done over here, and the work done over here, that is V2 minus V1, is what is known as electric potential difference. So students, here we have got two definitions, that is, at the time of electric potential, work is done to bring the charge from infinity to one point, and at the time when we are supposed to find the electric potential difference, the work is done to bring the charge from one point to another point. Clear? So this is the only difference between electric potential and electric potential difference. Okay? That's it with the